Alright, so we have our earthquake data visualized using a graduated symbology, using the event magnitude as our field, and using natural breaks as our data classification. And we can see here on our histogram that our data, these are the breaks here, and we can see how the data is distributed within those breaks. Right, so we have all of these low events in one, kind of these medium low in another, these ones in our third data class, and then these in our fourth data class. And what this is doing is essentially, since so much of our data is in these top two here, a lot of our, and because earthquake data is exponential, or magnitudinal events are exponential, in that a 6.0 earthquake is not just one linear step higher than a 5.0, which is one linear step than a 4.0, but those are actually felt on a logarithmic scale where each magnitudinal event means 22 times more severe of an event, more or less. And so we want data that really kind of clumps together a lot of these low magnitudinal events together, like below 5, and then kind of explores some of these ranges in here with a little bit more depth. So if we were to change this to quantile, for instance, this kind of makes the problem even worse, right? Now this data is chopped up so there's an equal number. Say we had 1,000 observations, then 250 would be in this bin, 250 in this bin, 250 in this bin, 250 in this bin. So quantile data classification works really well for an evenly distributed data set, right? A normal distribution. This is a skewed distribution, so quantile is inappropriate for this type of data, right? Because it's sensitive to outliers, it's sensitive to a skewed distribution, right? So in this case, our highest data class above 4.7 is all of these large circles, right? But what we really want to emphasize with earthquake data is that these events down here are significantly different than events in this big chunk here. So we can go to equal interval. And what equal interval does is it basically takes this range of data, so from 4 to 7.3, and then creates equal distant midpoints between those. So in this case, we have a lot of our data is in here. You can even see like the mean value is here. So a lot of our data, the bulk of it, is in this lower data classification, which is a small point. Then some in here, and then very few in these top two. So this does a better job of showing that the high magnitudinal events are more rare and more severe than this kind of like swarm or this cluster of small magnitude events. And we'll just kind of tidy what I like to do when I'm get kind of an equal interval or have numbers that are kind of pretty close to what I want them to be but not quite, is you can go in and manually adjust them so it just makes a little bit more intuitive sense. So we'll say this lower class is all below 5. Right, the second class is all between 5 and 5.5. We'll make this third class all earthquakes between 5.5 and 6.5. And then this largest data class is all the ones above 6.5. So that is a more effective way to visualize this data, to work with the histogram and the data classification, and then manually adjust and make nice intuitive values over here.